guys, in this second video, we're going to go through another example of how to factor a trinomial using the AC method, but this time our leading coefficient will not be 1. If you already feel comfortable using the AC method, you do not have to watch this video. This is just if you want to see a second example. Once again, here are the steps to using the AC method. You can feel free to just read through them and refresh your brain. And if you aren't sure about a step, go back to the introduction video and take a look at that. Okay, so let's look at our second example. I'm going to go a little bit faster through this one and not break it down quite as much, but we'll still go through each step together, okay? So remember, I see the directions. They say factor 2x squared minus x minus 6. I see the directions factor and I think to myself, okay, my answer better be in the form of factor times factor when I'm finished with this, okay? So I write that down right next to my directions so that my brain knows to go back and check and make sure that when I'm done with this problem, my answer is in the form of factor times factor. Okay, so now, the very first thing I always do is I check this for an overall GCF, okay? So when I look at 2x squared minus x minus 6, I see that there is no overall GCF. The coefficients don't have anything in common. The variables don't have anything in common except for 1, of course. So I do sort of have a GCF. It's 1, but not anything that I'm going to pull out. So now my next step when I'm asked to factor, first I look for an overall GCF. Second, I count the number of terms. 1, 2, 3 terms, which means I am using factoring with the AC method, okay? So the first step of the AC method is to label my A, B, and C, my coefficients. Here, my A is 2, my B is -1, and my C is -6, okay? When you're labeling those coefficients, it's so important that you take the sign with them. So if you have a minus sign in front of one of the coefficients, it comes with it as a negative, all right? So now my second step to the AC method, I multiply A times C, which will give me 2 times -6, right? My A was 2, my C was -6. 2 times -6 is -12. The next step I'm going to do is draw my table because I need to find 2 factors of A times C that add to B. So on the left side of my table goes multiply, and guys, I do this every single time. I make a table. On the left side, I write multiply, A times C, and I write what that equals. And on the right side, I write add, and I write what my B equals. Because I need 2 factors of A times C, which is -12, that are going to add to B, which is -1. So I'm going to start on my left side, my multiply side, and I'm going to think of all the factors that I possibly can for -12. And I always just start with 1, right? -12 divided by 1 is -12. So my first set of factors is 1 and -12. Then I move to 2. And if you need to, you just grab your calculator and you just do this on your calculator. -12 divided by 2. That goes in evenly. -12 divided by 2 gives me, or excuse me, yes, -12 divided by 2 gives me -6. So my next set of factors is 2 and -6, okay? Now I'm going to go to 3. I've divided by 1, I've divided by 2, now let's divide by 3. -12 divided by 3, that gives me -4. So my next set of factors is 3 and -4. And I'd actually keep going, you guys. I'm going to stop here just for the sake of room, but I would keep going. Okay, does it divide by 5? No, it doesn't. Excuse me, does it divide by 4? Well, we know it does, right? Because we see this pair of factors here. So I could keep going. I could do 4, and now my negative is going to switch, right? That's going to give me -3. Okay, it doesn't divide by 5. It does divide by 6, and that's going to give me -2, blah, blah, blah. And we would get our last set of factors, which would be 12 and -1. Now, if you'll notice, when you're dealing with a negative AC, you're going to wind up with 2 sets of factors where the negative sign just sort of reverses. So my first set was 1 -12, and my last set is 12 -1. So the negative sign just sort of reversed, and that happened for every single pair, right? The negative sign just kind of reversed. So whenever you have a negative AC, that's what's going to happen, all right? You're going to get one list of factors, and then the negative and positive signs will reverse, and you'll get the second half of your factors. So now I need to go through and figure out which pair of factors adds to -1, okay? So I'm going to just start with my first pair here. Okay, 1, negative 12. Well, 1 plus negative 12 gives me negative 11. That does not add to negative 1. Let's go to my next pair of factors. 2 and negative 6. 2 plus negative 6 gives me negative 4. That does not add to negative 1. Okay, so that's not my pair that I'm looking for. Let's try 3 plus negative 4. 3 plus negative 4 does add to negative 1, so that is indeed the pair of numbers that I am looking for, okay? So I found my factors of 12 that added to negative 1, okay? Now I can move into my next step. I'm going to replace the b term with those factors, okay? So that will give me 4 terms so that I can do factor by grouping. So here's my original trinomial, 2x squared minus x minus 1. I threw that 1 in so that you could see that when I replace my b term, I'm replacing this negative 1 with 3x and negative 4x, and I got those factors right from my table, right? Those are the ones I was looking for. This polynomial and this polynomial are completely equivalent because 3x minus 4x is negative 1. So 2x squared minus x minus 6 is the same thing as 2x squared plus 3x minus 4x minus 6. Okay, they're completely equivalent. All right, so I can do that. It's mathematically sound. But the reason that I did that, why did I replace my b term with those two factors, right? Because I wanted to use factor by grouping. And when I replace it with my b term with those two factors, I now have 1, 2, 3, 4 terms. So now I can, of course, do factor by grouping, which I'll finish on the next page. So let's take a look at that. Okay, so now I've taken my trinomial, I've used the AC method to turn it into this new polynomial that's got 4 terms so that I can use factor by grouping, right? And we should be starting to get really comfortable with factor by grouping by now. If you're not, make sure you go back and do some more practice problems. So we do factor by grouping, we split it right down the middle. Now we have a left side and a right side. So I'm just going to completely ignore this right side so I can focus on the left side. I'm going to take that left side and factor it first. How do I do that? Same process, you guys. I asked myself, is there an overall GCF? Why, yes, there is. That GCF is x, right? Both of these terms share x and nothing else. So that's all they have in common. So that is my GCF. When I factor out that GCF, it leaves me with 2x plus 3, which gives me a final factorization of x times 2x plus 3. If you are not sure where I got this from, because I know I'm sort of speeding up the process now that we're doing more and more of these, what you are going to do is pause this video, take this polynomial right here and divide by the GCF, okay, and see what you get, okay? If you're still feeling uncomfortable with jumping straight from here to here, okay? So that is what I get when I factor the left side. Now I'm going to completely ignore the left side. I've factored it, and I'm going to focus on the right side, all right? I need to factor the right side, negative 4x minus 6. Same process. I'm going to ask myself, is there an overall GCF? Why, yes, there is. It is negative 2. Both of these terms share a factor of negative 2. So when I factor that out, I wind up with 2x plus 3. And when I write the factorization of that, I get negative 2 times 2x plus 3. Okay? And again, if you're not comfortable with jumping from here to here, then you need to pause the video, take this negative 4x minus 6 and divide each term by your GCF by negative 2, see what you get, and do it out the long way, okay? So when I factored both sides, I can now put it all together back into a polynomial, which gives me x times 2x plus 3, right? That came right from here on the left. And then, of course, plus negative 2 times 2x plus 3, which came right from here, all right? So why did I do all that, guys? Because now, look, now this polynomial has a GCF, okay? And it should jump right out at you, guys. When you do the AC method and you get to this factor by grouping stage, and you factored both the left and the right side, the new GCF should be completely just obvious to you, right? It should jump right out that both of these terms share a 2x plus 3. Your new GCF should be incredibly obvious to you. So my new GCF is 2x plus 3, so I'm going to factor that out, okay, and write it in its new factored form. And when I do that, I'm left with x minus 2. And guys, when you get to this point right here and you're factoring out that new GCF, you can just see the new term, right? So or the new factor, excuse me. Our new factor was x minus 2. Well, it came right from here, x minus 2. Because when you take out the 2x plus, when you remove your GCF of 2x plus 3, they cancel, and you're just left with x minus 2, right? So that's where this is coming from, okay? You can see it. It becomes really obvious when you start doing more and more of these. There's the x minus 2, okay? So and of course we can never forget to put, our GCF is always a factor when you're putting things in their factored forms, right? So that's where the other piece came from. Now that I've finished this, I need to just say to myself, oh wait, at the beginning when I did this, was there an overall GCF? And if there is, I would have need to included it in this factorization. But we didn't have an overall GCF when we first started this problem, so we don't need to remember to go back and put it in. And I should, of course, be asking myself, when I'm done with this problem, is it in the form of factor times factor, right? Remember, way back at the beginning of this problem, we wrote next to the directions factor times factor, and we said our answer should look like that. And yes, indeed it is, if we have a factor being multiplied by a factor. So we did this problem correctly, okay? So that is the AC method. I know that seemed like a lot, pretty lengthy. My best suggestion to you is to just practice these problems. Do your homework. If you want more practice problems, I can give them to you. I think there's some in Blackboard right underneath this lecture. Okay, practice, practice, practice the AC method. I promise you, I know it looks intimidating now. The more you do this method, you are going to get so fast with it, okay? It just takes practice, and you're going to get into a rhythm with it. You're going to get into a really good rhythm with it, okay, as you go through those steps. And if you need to go back and rewatch the examples as many times as you need, that's the great part about taking a class online. You can go back and rewatch the lectures, use the PDF that I include in the lectures to take notes. So reach out if you have any questions. But first, before you reach out to me, you have to at least try. So you have to at least try to digest this, to practice it. If you're not understanding it, to go back, watch the lecture, take some notes, do it step by step along with the video. And if you're really still not getting it, then you reach out to me, okay? But you have to at least try it first, all right? So I'm wishing you all my best of luck. I know you guys can do it. You are totally capable of this. You've got it, right? So have fun. Good luck. I'll throw some more examples onto the next slide for you guys, all right? Bye. Here are those same 3 on your own examples for you guys to try. So if you didn't get a chance to try them in the previous video, give them a try now. Remember to go back and rewatch this video as you work through them. Pause at each step as you try them on your own. Okay, good luck. Bye, guys.